All right, hey guys. Yesterday we talked about finding the slope of a line. Today we want to talk about finding the y-intercept of a line. It is actually easier than finding the slope. So today we're going to go over notes for section 7.2, and that should have worked. Our goal today is to find the y-intercept of a line, either from a graph or from an equation. We will take them separately. I think we're going to start with a graph. The y-intercept of a graph, okay, this is the definition of what a y-intercept is. It is the y-value of the ordered pair where a line crosses the y-axis. All right, now technically, the point at which a line crosses the y-axis is an ordered pair. On this graph right here, this would be the point where the line is crossing the y-axis. And we should be able to name that point. Hopefully you know that that point is the ordered pair 0, 3. All right? X value is 0, Y value is 3 for that ordered pair. Now, since the y-intercept, right, the y-intercept is always going to be a point on the y-axis, we know that the x-coordinate of any point that's on the y-axis would always be 0. And so usually the y-intercept is only given as the y value of that point. For this one, we would say that the y-intercept is 3 because it is given that the x value is 0. Every point on the y-axis has an x value of 0. And one more thing about the y-intercept. The variable that stands for the y-intercept, now this is a little bit weird, but it is the letter b. I am guessing, but I think that could be because the y-intercept is usually considered the beginning amount, like with the tile patterns at figure 0. So we would say in this case that b is equal to 3. B stands for the y-intercept. All right, so now you know what the y-intercept is. It's the y value where a line crosses the y-axis. Let's see how to find it. I have 3 examples here, and for each of these I'm asking you to find the slope and find the y-intercept. Maybe you would like to pause the recording for a minute, see if you can fill them in, and then come back and see if you got it right. Here we go. To find the slope, I would pick 2 points and make a slope triangle. 1, 2, 3. 1, 2. And I would find that this line has a slope of 3 over 2. And because it's going down, it's a negative slope. Did you remember the negative? And then I need the y-intercept. Well, this line crosses the y-axis right here. It looks like that's at 2, so the y-intercept is 2. In the second example, first I'm going to find the slope by making a slope triangle. Looks like that's a good point, and that's a good point. And so my slope triangle would have a rise of 1 and a run of 4. And of course, the slope is equal to the rise over the run. So in this case, that line has a slope of 1/4. The y-intercept for this line is right here. That's -3. This line crosses the y-axis at -3. And the last line, the last example, looks like it has a nice point here and here. So my rise, 1, 2, 3, 4, it has a rise of 4, and it has a run of 1. Therefore, the slope is 4 over 1, or it'd be better if we just wrote 4. And the y-intercept, right here, looks like it's at -1. Okay, so hopefully pretty easily when you look at a line, you can identify what is the slope of the line and what is the y-intercept of the line. How about instead of from a graph, could you just look at an equation? If I gave you an equation, can you find the y-intercept without graphing it? Well, this is also fairly easy. Let's look up again real quick at the beginning. Here's what I claim, you guys. I claim that this is the y-axis. I don't claim that it is. And every point that's on the y-axis has an x value of 0. Like this is the point 0, 1. This is the point 0, -2. The red dot here is the point 0, 3. All the ordered pairs that are on the y-axis have an x value of 0. And we can use that fact to help us find the y-intercept in an equation. So I wrote here, the y-intercept is on the y-axis. And at the y-intercept, we know that the x value of that ordered pair is 0. So if you are given a linear equation, remember how we graphed linear equations? We put 1 in for x and we found y. We put 2 in for x and we found y. Well, what if we put 0 in for x? We could find the y value that is on the y-axis, and that would be the y-intercept. So we're going to put 0 in for the x variable and then solve for the y variable. And that y value is the y-intercept. Let's see a couple examples. Oh, mercy. Is that where I want to go? I guess it is. All right, well, I guess I'm going to actually start with B because that is what we just did. If I want to find the y-intercept, the first thing I do is I put 0 in for x. And putting 0 in for x really just cancels out the x term. 4 times 0 would be 0, of course, and really 0 does not add anything to our equation. So when I put 0 in for x, I'm really left with 2y equals -10. And then to solve for y, I would simply divide both sides by 2, and I would get y equals -5. When x is 0, y equals -5. Well, -5 must be where this line crosses the y-axis. This line must have a y-intercept of -5. Like if I was to graph this line, one of the points on the line would be down here at 0, -5. All right. Letter A. Could this be an uglier graph? I'm not sure where I got this from. But here is the y-intercept. It looks like it's crossing the y-axis right there, and it looks like that is -2. And I have 2 more examples. So for this equation in letter C, what is the y-intercept? Well, I would find it by putting 0 in for x. And 2 times 0 minus 3 is negative 3. So the y-intercept is at negative 3. By the way, on the homework, I think sometimes I ask you to write that as an ordered pair. As an ordered pair, that would be the ordered pair 0, negative 3. And over here, what is the y-intercept? Well, put 0 in for x, and I get 2 times 0 plus 3y equals 12. That would just be 3y equals 12 because 2 times 0 is 0. And if I divide both sides by 3, I get y equals 4. The y-intercept is 4, or it's at the point 0. Oops. Let's try that one more time. It's at the point 0, 4. All right? I hope you can find the y-intercept. Good luck on your homework.